Today, we're diving into something that sounds like science fiction, a box that can pull clean, drinkable water right out of the air, even in the desert. And the most amazing part, it uses zero electricity, has no moving parts. This is a solar cube, and it could be a game changer for water scarcity. The solar cube is a new device that uses sunlight to passively pull humidity from the air at night and release it as ultra pure drinking water during the day. It's a huge deal because it's durable, scalable, and zero energy way to provide clean water to remote areas, disaster zones, and off-grid communities that have no access to a power grid or water infrastructure. What do you think about this, John?
I absolutely love this. So imagine a simple wooden cube, okay? It's the size of a coffee mug, and it can literally pull drinking water out of the thin air using nothing but sunlight. This quote-unquote smart sponge, it works like nature's own water cycle in miniature. So during the night, or when the lid is open, the specially treated balsa wood absorbs moisture from the air around it, just like a super efficient sponge. Then when you close the lid and put it in sunlight, the solar energy heats up the material and releases the pure, clean drinking water that drips into the cup below. So how it works is they've engineered what they call quote-unquote WLG-15. So it's a wood-based composite material, and it represents a crazy breakthrough in atmospheric water harvesting. So it exploits the naturally porous architecture of refined balsa wood as a three-dimensional scaffold, which is then infused with lithium chloride, which is deliquinous salt, and then iron oxide nanoparticles for the solar thermal conversion. And finally, a carbon nanotube layer for enhanced heat distribution. So they've combined nature with science, which is really cool, and created a hydroscopic material with a crazy water absorption capacity, capable of absorbing up to 2 millimeters of water per gram of material at 90% relative humidity, and still achieving 0.6 millimeters per gram at 30% humidity, where most atmospheric water generators fail completely. So no moving parts, no electricity needed, just natural sunlight. I think this is phenomenal. What are your thoughts on this?
Yeah, I mean, not needing a ton of energy or fans like they do right now, any of these methods that they have. This is great. The researchers show it's freeze resistant, tested down to negative 20 degrees. It keeps working efficiently cycle after cycle. It makes it perfect for harsh environments. And the water is super clean. The natural purification method leaves behind bacteria and viruses, dissolves salts and minerals, heavy metals and toxins, and other harmful contaminants. No additional boiling or purification steps are required. It sounds great. Like, using this for disaster relief, humanitarian aid, off the grid living, or community scale water, because you could modularize these like Lego to produce more and more and more. And maybe people have these on the roofs of their houses or whatnot at some point to produce clean, drinkable water for them when things start getting bad. But I like the real concept. They didn't mention price. Do you know the cost?
I don't. Hold on. Let me just look at my notes here. No, I don't see any cost here. But it says projected market growth 6.2 to 12.7 billion by 2034 for water crisis. But that doesn't speak to the price of this. No, but yeah.
And there's some concerns about scale. Like performance is measured in millimeters per gram of material.
Yeah.
So that means you need a lot of material to produce gallons of water. So it's scalable, but a community version might be the size of shipping containers or larger to do more and more and more of these. So you have to consider that. It's also not a magic bullet. It still depends on having some humidity, at least 30%, and critically reliable sunlight. It won't work as well during long stretches of cloudy days or in extreme cold temperatures. So it survives the cold. It just won't be producing a lot of water in that cold.
Yeah. The cool thing that we didn't touch on is the development process itself, how they developed it. they actually used machine learning and AI. So they incorporated ML algorithms to optimize device performance across varying environmental conditions. So that represents kind of a new paradigm in atmospheric water harvesting system design. So the AI models, what they did was they analyzed the complex interactions between ambient temperature, humidity, solar irradiance, airflow patterns, and material properties to predict optimal operating parameters in real time. So this approach enabled the team to fine-tune the balance between water absorption capacity and release efficiency, which identified those precise ratios of the wood and materials that enabled them to develop this. So I feel like if they use that same AI or that same LLM, that's what's gonna help them to scale this.
It sounds like it. So, and again, this isn't theory, it's working. They have these working devices working at 94% efficiency. So it seems like it's just now a matter of scaling them and getting them to where they're needed the most.
Exactly. Yeah.
So that's all we have time for the solar cube. It's an incredible piece of engineering that works with nature, not against it. And we'll be watching to see how quickly they can scale this from a successful research project to a life-saving product in the field. So what do you think? Is this the future of water for off-grid communities, or is the scale challenge too big? Let us know what you think. So what do you got going on, John?
Yeah, well, just helping companies secure government funding. So, it's a great time to reach out if you have any questions. How about you, Craig?
Well, there's a lot going on over at flowgrammer.ca. We're doing automation and AI and business processes. We do events, but we're really ramping our business up. And check out all the things we're doing over there. If you're interested in business automation, we've got community events where we're teaching everyone. We do an online, and we're about to launch our new resource center, flowgrammers.ca, which might be out when some of these are out. Other than that, check out for everything we do. Our monthly startup investor drinks, where you get to pitch to the crowd, business owners and investors, and have real conversations and make real connections. So for all those things, check out torontostarts.com. And for everything else, anything else, John, before we say goodbye?
No, just reach out to me on LinkedIn, John Irwin, if you want.
John Irwin on LinkedIn. Thanks, everyone. We'll talk to you soon.